Hello, everyone. Mr. Schultz here, coming to you live from the classroom. We're going to do a practice day over Unit 3. So, without further ado, I'm going to share my screen and we will get started. Okay. So, for Unit 3, we've been dealing with area and perimeter. We're not going to stop. That's what this practice day is over, area and perimeter. Remember, perimeter means you just add up all the sides. So let's kind of start number one. What shape is this? It's a parallelogram. For the perimeter, we want to add up all the sides, not the dotted lines, the solid sides. So like this side is 7.5. This side is 10. We're going to add up all the sides. It's going to be 10 plus 7.5 plus 10 plus 7.5. So that's going to give you 15, 25, 35. And our units would be in inches. Now, if you look on your formula chart for the area formula, what does it say? It says that area equals BH. That's base times height. So our base is going to be the 10. It's going to be what it's sitting on. The 6 is our height. Base times height. So now we can plug in. It's going to be 10 times 6, which equals 60 inches squared. Okay. Next shape. I want us to name the shape. This is a trapezoid. Again, for perimeter, you add up all the sides. Don't include this dotted line. That's not part of the sides. That tells you your height. I'm even going to go and mark that. 8 is your height. It's not a side. Don't include it. So our sides would be 9 plus 22 plus 12 plus 37. Let me get my calculator and add that up. 80. This one's going to be 80 inches. I guess I could come in here and box in my answers. Okay, so for the area formula for a trapezoid, what would it be? If you look on your formula chart, what does it say? It says A equals 1/2 base 1 plus base 2 times your height. The bases are the parallel sides. So it doesn't matter what you call base 1 or what you call base 2. As long as it's the parallel sides, you're good. So I'm going to call 22 base 1, 37 base 2. That's what we're going to plug in. So 1/2 of 22 plus 37 times 8 equals, well, let's see. $236, and we're in inches squared. Okay, keeping it moving. Number 9 says name the figure. This is a triangle. So let's find the perimeter of this triangle. Well, add up all your sides. 9 plus 12 plus 15. That gets you 36 centimeters. For the area formula, if you look on your formula chart, we'll say area is 1/2 base times height. Your base is what it's sitting on. The height is the one that goes straight up and down. So now we can plug in. A equals 1/2. 12 times 9. That's going to give us 54 centimeters squared. Our next shape, what shape is it? It's a rectangle. So remember, on a rectangle, opposite sides are the same. So 2 and 7. To get the perimeter, we can just add them up. 2 plus 7 plus 2 plus 7. It's going to be 18 millimeters. We look on the formula chart. What does it say for area? Area is base times height. Our base is the 7. Our height is the 2. So 7 times 2 gives us 14 millimeters squared. The next shape. The next one is a kite. Now on a kite, the long sides are the same. So this side's also 34 meters. The short sides are the same. So that side's 20 meters. For perimeter, you just add them all up. 34 plus 34 plus 20 plus 20. So give you 108 meters. For the area of a kite, it's the same as the area of a rhombus. Area equals 1/2 D1 times D2, where D stands for your diagonal. But we've got to be careful here. We have to get the whole diagonal. For instance, this one right here. They tell us each piece is 30 and then 12. So that means if we call that D1, D1 is equal to 30 plus 12, which is 42. This one right here. Not that you can see the highlighting much. I guess I could go like this. That one. 16 and 16. So if we call this D2, we could say D2 is 16 plus 16, which is 32. Now we've got D1 and D2, so we can plug in. So 1/2 of 42 times 32. Let's see what that's going to be. $672 meters squared. Our next shape. This is a rhombus. So on a rhombus, all sides are the same. It's like a tilted square. So for the perimeter, you could say 4 times 20. I'm just going to keep it simple and just say add all sides, which in this case, they're all 20s. So that's going to give us 80 centimeters. For the area formula, rhombus and kite have the same formula. Its area equals 1/2 diagonal 1 times diagonal 2. Diagonal 1, they tell us is 12. Diagonal 2, they tell us is 16. I believe that should be 96 centimeters squared. Let me double check, but I'm pretty sure that's 96. It is. And next one, find the circumference of circle P in which the area equals 49 pi inches squared in terms of pi. Okay, so we want circumference. But they give us area. We have to get the radius out of the area and then turn around and find the circumference. So they say area is 49 pi. So pi r, 49 pi equals pi r squared. The pi's cancel. This leaves you with 49 equals r squared. Square root it, and you get 7 equals r. So your radius is 7. Now I can take this 7 and come over here and plug it in to the circumference formula. It wants it in terms of pi, so we are not going to put pi in the calculator. We're just going to leave it as 14 pi inches. That's our circumference. On 26, they ask for area of circle A. So they want, well, area of a circle is pi r squared, but they give us the circumference of the circle, which that formula is 2 pi r. So it's going to be a similar process. 48 pi equals 2 pi r. Of course, the pi's cancel. So we're left with 48 equals 2r. Divide by 2, and you get 24. So your radius is 24. We take that. Oh, wrong thing. We take that, and into our area formula, we have to plug it in. Pi times 24 squared. 24 squared is 576 pi. This is going to be in inches squared. That's our area. '27. Find the area of sector PQR. Give your answer in terms of pi and round it to the nearest hundredth. So we've got two parts here. Okay, so now we are going to have to actually put pi in the calculator. So this is the area of a sector. Remember, a sector is just a part of a circle. So for our formula, it starts off with pi r squared, but then we only want part of that circle. So times m over 360. Your radius is 26. Your angle is what they give you, so m is 90. We've got what we need to plug in, so let's do it. Pi times 26 squared times 90 over 360. Let's first give our answer in terms of pi. So 26 squared times 90 over 360. 169. So area is 169 pi meters squared. That's one answer. They also ask us to give it to the nearest hundredth. So we put pi in the calculator now. It's going to be 530.93 meters squared. Okay, number 7. Not 7, number 28. What am I thinking? Oh, wait, maybe I'm not. Dun, 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 dun. I'm teaching, but I'm not thinking. That's a scary combination. Find the length of arc PQ. So the length of an arc. That's our formula that starts off like circumference, 2 pi r, but we only want part of the circle. Okay, so what do they give us for radius? Radius is 18. Our angle, 120. We can now plug it in, 2 pi r, or sorry, 2 pi times 18 times 120 over 360. Let's see what that comes out to be. 120 over 360, that's a third. 18 times a third is 6. I'm thinking this should be 12 pi. It is. 12 pi meters. That's our answer in terms of pi. It also says do it to the nearest hundredth. So actually put pi in your calculator. It's going to be 37.70 meters. And 29, they give us this composite shape. Now, on these composite shapes, there's different ways you can break them up. There's not one set way to break these shapes up. So, just because I break it up one way doesn't mean you can't do another way. As long as we end up with the same answer in the end, that's what matters. So I think I'm going to break it up right here. And make a rectangle with a little triangle. So for this side, I would have to do 8 minus 5, which gets me 3. So this side is 3 of the triangle. The bottom of the triangle, I would have to do 14 minus 9 to get 5. So this side down here is 5. Okay, so now let's find the area of the rectangle first. That's going to be base times height. The base of your rectangle is 9. The height is 8. 9 times 8, 72. Now for the area of the triangle. That's 1/2 base times height. Now for our triangle, the base was 5 and the height was 3. So half of 15 is 7.5. And now for the total. Now on this one, we're adding two shapes together. We've got the rectangle with the little triangle added to it. So the total area, think of it like you're carpeting a room. The total area is 72 plus 7.5, which is going to give us 79.5 millimeters. Squared. Woo! This is area, millimeters squared. Squared almost caught me. Okay, and then 30, the last one. I think it's the last one. Yep, it is. Last one. So we see two shapes. We see a trapezoid. That's pretty much what's in yellow. But then somebody came in and cut a triangle out of here. Out of our perfectly good trapezoid, they stole a triangle. How dare they? But we can deal with it. So let's first find the area of our trapezoid. The formula chart says it's going to be 1/2 base 1 plus base 2 times height. So your bases on your trapezoids are your parallel sides. So 48 is going to be base 1, 102 base 2, and then the 18 is talking about the height of the trapezoid. The 12 is talking about the triangle. We'll get to it later. Right now I'm worried about the trapezoid. It's going to be 1/2 48 plus 102 times 18. Let's see what that's going to give us. (1,350 inches squared). Now that's just for the trapezoid. Now we need to find the area of the triangle. On the triangle, our formula is 1/2 base times height. The base of the triangle is 9. The height is 12. That's going to give us 54 inches squared. Now we are cutting out the triangle. We don't want a triangle in there. So I'm not going to add this time. This time I'm going to want to subtract 54. I think that's 1296. So 1,296 inches squared. Okay, so there is the guided practice. Well, no guided practice. There's the practice day. So just like in the past, on practice days, there are not guided practice portions. So, yeah, this is it. If y'all have any questions, you know how to reach me. Remember, you are created for wonderful things, and you are awesome. Always believe.